We bought our first blue box over 10 years ago, and we've been using AutoLogic ever since. I'm Edward Huang. We're here at MSpec Performance Lindenhurst. We do have two other locations, MSpec Middle Village and Essential Auto Care. We are BMW specialists. We do work on all European makes and models, and we also work on domestics and Asian imports. I used to think that I didn't need help, but as you grow in the industry, you just realize that you can't do it by yourself. It's impossible. As a technician, a lot of times we're working on more than one vehicle at the same time. So if I have an issue with a vehicle, I can put a claim in and then move on to my next car and work on that while I'm waiting for a call back. We have a pretty large staff, so I'd say that we are able to request support multiple times a day. Support to me is all-encompassing. AutoLogic does help with training, which is huge in our industry, on top of being able to diagnose, code, and having dealer-level abilities in a non-dealer tool. A repair shop definitely needs technical support. We in our industry like to think that we know everything, but with the pace at which our industry is evolving, you can't know everything. It's impossible. And having that technical support there really allows you to confidently go into any job.
Welcome everybody to Volkswagen's webinar on Volkswagen, or AutoLogic's webinar on Volkswagen Audi variable cam timing. My name is Chris Martino. We're going to be going through some stuff tonight. If you have any questions, feel free to ask them. We got some people in the chat that can help you out. If you have any questions for me, ask me. I'll see what I can do. So without any further ado, we should get started here. Just give me 1 second. We're going to change some stuff around. And we are going to do this. Okay, and let's do this. Let me turn my screen off. Okay, and let's launch this. All right, so Volkswagen variable valve timing and U. Let's get started. Hold on 1 second. There we go. So next slide. Whoa, there we go. All right, so we're going to start with one of the problems here. This is the bearing bridge for this car. What it is, it's basically a die-cast aluminum bridge. It's mounted to the front of the camshafts. All right, what this does is this, let me draw some pictures here. What this does is this carries the oil. Whoa, let's go try that again. This carries the oil from the cylinder head up and into the camshafts. All right, so it's actually a very important part when replacing this. Generally, when you take them off, you generally replace them because they're prone to breakage. Let's move on a little bit. So this is basically the heart of the system here. All right, so what you have in here is you have your cam magnet. All right, what that does is that is actually a solenoid type magnet that pushes a little rod inside a little valve that's right here. Let's get rid of some of this stuff over here. Pushes a little valve that goes inside your phaser right here. All right, it's a very complicated and convoluted setup here. All it really does is control the oil flow inside your phaser and allows your timing to move backwards and forwards. All right, so we'll read a little bit on what it does. And also, if you want, inside on your side menu over there, you should have a file download. In your download is going to be a book for the whole Volkswagen 2-liter 1.8 engine. Download that and save that. It gives you everything more than what we're going to cover tonight. It's going to give you tips and tricks, how everything works. It'll actually cover a little more than what we are doing tonight. All right, let's move on a little bit more. So again, we're going to cover the way this works. The way the heart of the system works here is the computer controls this solenoid right here. All right, it's a pulse width modulated signal, and it allows the magnet to move and open up to a varied amount, pushing on your oil valve, and that oil valve in turn moves your camshaft adjuster. It's basically as simple as it can get. We're going to go into that a little bit more on the next couple slides. Let's go take a look. So this is basically what we're looking at. Over here is the cam magnet that we were looking at. All right. What I did on this side is because a lot of people when they talk about these systems, they're kind of confused because it's all broken up. But one thing a lot of us really know about is this little guy right there. All right. That's a Toyota the VVT actuator. It's basically the same for pretty much any system, any variable valve timing system that you would see. But what Volkswagen did is, instead of mounting this in a cylinder head and oil passages going to the cam, going to an adjuster, they put it all in one little package. But you can see, if you look at it, it's basically the same thing. The solenoid is here, and the actual adjusting valve is here. And that's literally all it is. And so what they did is they screwed it right into the front of the camshaft, making the job that much easier to diagnose. All right, let's move on. This right here is the camshaft phaser. All right, on the Volkswagen 2-liters, some of the earlier ones, the chain drive 2-liter engines, the intake cam is going to be the only one that adjusts. The later generation 3 models, it's going to be intake and exhaust cam that adjusts, but it's going to all work similarly. It's all the same. All right. So what you have is what I'm pointing to right here. It's one oil hole where oil flows in from the cam adjuster that we were talking about before, and you have another hole which again flows in from the cam adjuster. Those are your oil inlet holes. All right. And you can see, if you see the threads that are inside right here, these little guys right there, that's a reverse thread that camshaft adjusting valve screws into. So what happens is you see it here lines up. So you can see that your oil holes line up as they move. It's actually a pretty simple system. Your camshaft adjusting valves screw right into the camshaft adjuster. All right, and I have a picture here of what everything looks like all together. So seeing it kind of like this, it kind of makes sense. So what happens is the camshaft magnet pushes this little nubbin right there. All right, that little nubbin moves a little block off right here and right there, depending on if we want to advance or retard timing. Retarding timing is basically cutting oil pressure off, letting it bleed down. Okay, that's basically all that's all about. So what I did here is I took the cover off of a camshaft adjuster. All right, they recommend you actually replace them, but if you actually just remove these bolts here and have the special socket, not like what I had where I just hammered in a regular torque socket, but you can actually take the cover right off. And inside, there's really nothing inside here. All right, you have your vanes here, which oil pumps up on either side of these guys, either retarding or advancing your timing. Okay, and then you have this little guy right there. That little guy is actually your little lock pin. All right, that guy with that horrible blurry picture, that's your lock pin. All right, the lock pin's job is when oil pressure is bled out of the system, it locks the cam to its most retarded position. Sometimes what happens, we'll get into this a little later, is sludge builds up and it'll lock it out. But that's basically all the parts that are in this. Let's go back a little bit. Let me erase some stuff here. Go back here. Okay. Go back. There we go. one thing that is not shown in here is right in this spot right here. Right in that little area, in those little areas right there, are little tension springs. All right, those tension springs, what their job is to keep constant tension and a nice gap between this surface and the vane itself. What sometimes happens, you see this more on earlier 2-liter Volkswagen engines, more of the belt drive in the front with the chain in the back. The the spring will actually break, come out and wedge, and you'll actually get a either a lock to advance or not able to reach your adjusted timing code. And really, sometimes all that is the spring popped out. Again, they don't really sell replacement parts for this, but between you and me and the hole in the wall, I've taken the spring out and I've been okay. So moving on a little bit. Again, this is the lock pin we were talking about. Again, that lock pin is very important. We'll get to it. So the lock pin that we see right here is, I have it sitting right here. All right. What the lock pin does is it goes in and locks the adjustment part of the housing to the back part of the housing that does not move. It brings everything and locked it together. Okay. Now what happens at about 7 psi, let's go to the next slide. At about 7 psi, oil goes in from the camshaft adjuster housing, goes into this channel here, flows up and fills up right here. All right, and when that oil fills up, it pushes the pin back and the cams are allowed to float. All right, this is a great thing. But if you look at the design, you can see an inherent problem or an inherent flaw in that design. The oil, that's a dead end path for the oil. If you're using wrong oil, incorrect oil, junk oil, or extended service intervals, the sludge likes to build up in dead ends, and that's a giant dead end path right there. All right, so what happens over time and over getting hot and the turbo breaking down the oil, sludge will build up in that path and it'll allow that pin not to fully lock. And over time, what will happen is you'll get codes that'll say camshaft, intake camshaft, retard set point not being able to be reached, something like that. All right, and what that generally is either a sludge buildup or the actual hole will be worn out. One of the things you can do to check that is pull the plastic timing cover off of the front of the engine and try to move this part of the camshaft. If you can move this part of the camshaft and this guy here stays still, then you know you got a problem with either an oblong hole or the lock pin itself. All right, this series of engine right here, the camshaft adjuster is not replaceable separate from the camshaft. So if you have a problem with your adjuster, you get a free camshaft with it. Earlier engines, the first generation 2-liter, were replaceable separate, and it was much easier to replace. So what we can see right here is a front look of everything taken off, but the vein still in there, and then you can see the sweep. So you can see with the oil flowing through this hole right here, it pushes this vein up here, up against the housing right here. And that gives you your full retarded position. And then over here, you can see the oil hole over here pushing it back. And if you look, we see a gap right there to allow that oil to flow either way, no matter which way it wants to go. Do we have any questions before moving on? Nothing that I can see. All right, so let's move on a little bit. All right. So if you read in the description and operation before, it says the camshaft adjuster gives you 60 degrees of crankshaft adjustment, and I want to know how it gets there. So I got a little nerdy with it, and I broke it all down. So you can see The phaser allows for 4 teeth of full adjustment. All right. This camshaft sprocket has 46 teeth. If you do the math, 360 degrees, which is all the way around a circle, divided by 46 teeth, you get 7.82 degrees of camshaft angle per tooth. Multiply that by the 4 teeth of total adjustment. That means you get 31.28 degrees of camshaft adjustment. Multiply that by 2 for rotation of crankshaft, and there's your 60 degrees. Pretty simple if you break it down, right? Okay, talking to myself. So what I did here is I took all the plates and everything off. You have the snout of your camshaft right here, right next to the camshaft adjusting valve. All right, so you can see, let's erase all this stuff here. Okay, go back to the pen. So this is the camshaft adjuster valve lined up to its respective ports in the actuated position. Here you can see the valves allowing oil in where they would flow into those particular holes. And then again, here you would see them deactivated. It's a cool side by side. You just go back and forth. You can kind of see them activated and not activated. Really cool. All right, moving on. So some of the basic tests you can do, one of the easiest tests, is to make sure that your actual and specified camshaft adjustment angle are within a degree or two. All right, generally you'd find that in measure value block 91. That's generally my go-to on this. And you want to see that your actual and specified on this particular car running at idle are at both commanded at 28 degrees of crank angle. All right. What happens now? Let's say what happens if it's not there, or you see your actual can't meet your specified, or your actual can't even stay the same. What you would generally do at that point is you would rev the idle up, see if it can match that, let it go down, and just see how long it takes to deal with it. All right. If it's moving a little bit, that tells me we're dealing with maybe like an oil flow problem or something like that. My next step would be check the oil pressure, see if that's good. If we see that it's not moving at all, then we check for like a camshaft adjuster magnet not working or something like that. Oil restriction is a very big deal in these engines, as we'll see in a little bit. What we're looking at here is the bearing bridge removed from the car. And you'll see right here, that little guy right there is a big problem. That is the oil screen in the camshaft bearing bridge. All right. When you take these off, or if you're suspecting a timing problem, say you get a code for your timing not reached, or stuck advanced, stuck retarded, or you're going and checking your measure value block 91 and you see that the actual and specified, they can't quite meet each other, or it takes a long time. First thing you're going to want to do is pull this bearing bridge off and look to make sure that screen is there. If it is not there or missing like that, we got ourselves a problem, because in our next slide we'll see it. What happens with these is the bearing bridge screen goes right here. Oil pumps up and in through the camshaft adjuster valve and the camshaft itself. So if you have pieces of tiny little pieces of screen like this, I mean, it's this one, like if you touch it, it just falls apart, and all those go in through the valve and up. And if you have tiny pieces caught inside either the adjuster or inside the camshaft itself or inside the phaser, that can make your timing problems much worse. All right. Here's another thing to look out for. The camshaft button, or the 4-3 valve, or the solenoid adjuster valve, whatever you want to call it. If you're having timing faults and you suspect the problem, one of the easiest tests to do is take the camshaft magnet out and look at that button. If it's stuck out like you just cooked a Thanksgiving turkey, that's a problem. That should be nice and flush, like this guy right here. All right. That's just one thing to look for. Another thing is if they're stuck in the complete other way, that's a problem as well. Alrighty, moving on. So, how can we test if all this is working properly? Some scan tools allow you to perform some form of output test. Almost all of these tools will not let you do this while the vehicle is running. On top of that, some tools, they'll time out and you must wait hours to test, again, with the engine off. The output test will tell you if the computer is able to control the system. It will not tell you how well the system operates. And that's true. Some tools, the AutoLogic tool can go in, you can run output tests all day long. As long as it has it there, you can run the test. Some tools, like I used to use a launch all the time. You get one test if it has it. And you run through the test, and if you don't have everything ready, you're locked out for a couple hours. There's nothing you can do. But again, even that, you can't actuate this camshaft adjuster valve while the vehicle's running. It just won't let you. So how can we test if this is working? Well, what I do is I grab my AES Wave front probe set. What this kit has, it has almost every different type of connector that is in and out in an automobile, where you can front probe it. You can also do pin drag tests, which are very important. We'll speak on that in further webinars. But you can also build your own little breakout box, kind of. But what I love to use it for is actually activating components separately without shoving a power probe or a test light in that connector, making more problems. Moving on. What you're going to need is a diagram. In this case, I just pulled an aftermarket diagram off showing the entire vehicle. So we got 4 pages of diagram here showing pretty much everything. All right, but what I'm looking at is what I want to see how far the camshaft is able to adjust on a running vehicle. What this will tell me if I'm meeting that 60 degrees that we proved before that this is actually able to make. So it should be able to make it with oil pressure. What are things that can impede that? What we talked about, pieces of that screen being broken, the spring in the phaser being broken, sludge could be broken, causing a lot of problems in this, bad oil pressure, stuff like that. And I want to be able to, if I have a timing code and I see that my chain timing is on point, then I want to make sure my variable valve timing is fine, because your timing is read from the camshaft and the crankshaft, not the timing chain. So your variable valve timing has to be working, because that's where the computer reads it from. So I'm going to want to check this from either the cam sensor, crank sensor, and I need something to reference it again. And sometimes these cars, the crank sensor, especially on a front wheel drive, like a Volkswagen or something like that, the crank sensor is going to be really tough to get to. So I opted to I want to try to use the cam sensor. Okay, so we're going to tap into the signal wire of the PCM for the PCM for that sensor. What that'll do is it'll output a signal and it'll let me know that the cam sensor is working. If you don't know which wire it is, you can look at the diagram, and there's an easy way to tell it. All right, if you can see that it's a 3-wire signal, so you know you're gonna have a power, a ground, and then a signal return. All right. You can see that these 2 wires are spliced together, so those can't be the signal wire. You can also see that those 2 are spliced together, so that can't be the signal wire. So that leaves the only one to be correct. So we have a question from Samuel Bain. He says, so the top piece is magnetic, correct? If so, why have a magnet when it is actuated by oil pressure? Great question. The top piece is in fact it's an electromagnet. All right, it's an electromagnetic solenoid. So when the solenoid is activated, it pushes a pin. Let me go back to that picture here. It's a great question. Let's go back to it. Where are we? Here. All right. So this is what you're talking about, the top piece. This is an electromagnetic solenoid. When the solenoid is activated, there is a little pin right there. All right. That pin shoots out and pushes that rod right there. So if the magnet goes bad, you're not going to get oil pressure. Also, if you have oil pressure that's bad, you could push this all day long. If there's no oil pressure, you're not going to be able to make enough pressure to move these adjusters. It's a great question. We have another question from Jonathan. He asks, what oil change interval do you recommend? Oil brand? We use Liqui Moly at the shop I work at. John, so do I. I personally love Liqui Moly. I put it in everything I own. I'm not really, I'm not getting paid for anybody for saying this, but Liqui Moly I found is an expensive oil. But what I've seen in some cars is cars that have a lot of sludge buildup, it'll actually start cleaning it out. My car I drive personally has 250,000 miles. I've been putting Liqui Moly in it for about 5 years now. If you take it apart, it looks like a brand new car. I trust that stuff. As far as intervals, Volkswagen, Audi, BMW, they always specify these long intervals. Personally, I don't trust it. 5,000 miles is what I do. I don't care what they say. It's not going to hurt me to put a little extra oil in it. Great question. So let's see. So we have Andrew says, so if that screen is broken, should you be replacing everything, including bridge, phasers, and solenoids? Awesome question. If that screen is broken, first thing you're going to do is look for all the pieces. If you can't find the pieces, then you go hunting. General rule of thumb with that bearing bridge, even though the screen is replaceable, and even the new bearing bridges that come without the screen because it's such a problem. Because Volkswagen seems to love their screens. Later on we'll get to talk about balance shafts. That'll tear an engine up, but that's a whole nother problem. Yes. Where was I? Yes. Rule of thumb with the bearing bridge. If I'm taking the bolts off of it, it's getting a new bearing bridge because it's just so sensitive. If the screen is broken, maybe you're lucky and everything is just lying right in that little hole. If not, you got to find the pieces, and that part's going to suck, unfortunately. You got to go hunt up. Hopefully you find them all. Hopefully you find them in the housing. Hopefully they're not caught in the phaser. All right, great question. So let's move on to where we were. So we were about, say, here. All right. So we're getting away how to find the signal wire without knowing or taking things apart. So again, a good aftermarket diagram like this is a really good way to check it because it shows everything that's spliced together. All right. I want to reference this. with ignition sync. You can use the crank sensor if you want, if you can get to it, but I needed something that was repeatable. So I figured I'll go to the number one ignition coil. So you can see that it's basically the same process of elimination. If you don't know which one it is already, generally it's this wire right there. But you can see that it can't be this wire because it's being shared. It can't be this wire because it's being shared. It can't be that wire because it's being shared. Leaves only that guy right there. Simple enough. So this is how I have it set up right here. Just like this. I have one channel of my lab scope hooked to a power probe that I'm going to be actuating the solenoid with. All right. I also want to know when I'm actuating the solenoid. So I put it, like I said, I put a channel on the power probe and the other end of the power probe of my power probe 1, because I don't believe in anything more than that. The other tip of the power probe goes into the solenoid power and ground. The other channel that I have goes to my number 1 ignition coil right here. Just tapped into the wire, pierced in. Don't worry, I cleaned it up when I was done. And then the third channel, which you can barely see, you can barely make it out because it's underneath my mirror because I'm a moron, goes right to the cam sensor, which is right here. Like I said, this is the easiest, quickest way to test this thing because you're right up top. You're not lifting the car up. You're not going crazy. The most you're doing is pulling the little plastic annoying cover off the top of the engine. All right. So again, you see, I'm I'm into the signal wire of the ignition coil number 1 right there. Now, what I wanted to also do is the camshaft adjuster valve, that magnet. We want to get into that and actually actuate it. Now, do you have to go this far? No. One thing you can do that some people do is actually take off the cam magnet, which lives right here, run the car, and press the button in that the magnet would normally press with like a pencil or your finger or something like that, something that won't get hurt, and actually activate it. But I want to be able to record the whole adjustment event. So that way, I just go and I'll hook my scope up to it and activate it with a power probe. That way I know what's happening. All right. So basically what we're going to do is hook up to the camshaft adjuster valve, which is right here. This is basically what I'm going to do. I'm going to disconnect it, hook up my power probe, and what I did is I made sure to use these front probing connectors right here. All right. If you want to go and use alligator clips and everything, you run the risk in a tight spot like this of shorting something together and then causing yourself problems. So I like to use front probe connector so I know I'm making a good contact and there's no way the wires can touch. All right, just like this. All right, so I'm set up. I start up the car. All right, and all I'm going to do is I'm going to run the car and just hit my power probe. You're not going to stay on it. If you stay on it, you could cause a problem to the solenoid. You could start the car. So you run the car and just click the power probe. Pop, pop, pop. That's it. That's all you need. That's all it needs. All right, and as long as you're recording, this is what you can see. All right, you can see this, and I have this on a picoscope. And actually, if you look now, we have a special offer that's going on with this webinar. You get a free picoscope with the purchase of a Drive Pro to do stuff like this. If you don't have a pico or don't have a scope, it's a great scope to use. It actually works well with everything that we do here. But going back to the webinar, you see that we can see our blue trace is the cam sensor signal. You can see the ignition module signals are in the red, and when I activated the power probe is in green. Now you can see this is why I wanted to hook the scope up to it, so I know when I adjusted it. Because if I just went and moved everything, I wouldn't know when it was moved. All right. So what I wanted to do is you can see a complete timing adjustment event. You can see the ignition moving in relation to the camshaft as the power probe is activated. And so I want to measure this. So I'm going to put cursors right here, these guys right there, at an ignition but before and after I activate the power probe. So I can see how much it moved. Now you can actually see, let me erase this on my slide a little bit. As you can see, if you look, go back. Let's do this one more time. Here we go. You can see right here, the red is every time the ignition coil is firing. Now that's going to move in relation to the camshaft. And you can see that this is in the same spot as this spot. But here is when I press the power probe. And you can see, if you look, the red spot in relation to the blue is changing as time goes to here. So you can see that it's adjusting. All right. So again, you can see where I activate the power probe. Just remember, you want to activate the power probe in short little bursts because you don't want to stall the vehicle or damage the solenoid. We're only checking here. All right. Now you can see we're measuring 2,880 degrees of crankshaft rotation if we use our rotation rulers. How do we get here? Number one ignition fires every 720 degrees, right? So, you know, we got 2 revolutions of the crank is one full ignition, one full combustion event. All right. We're measuring the ignition events between the cursors. There's 4 of them there. So 4 times 720 is 2,880. So in a pico, you put out what you're going to measure right here. And then from everything, the way the pico works is everything that you adjust from your rotational rulers will adjust from this point. And again, if you want to learn more about this, we'll do more picoscope videos in the future. But for now, let's just follow along. Now again, we want to have something to reference against. So I'm gonna reference against this little first small pulse in every single cam adjustment event, because it doesn't move in relation to the timing. So and it's also, you can zoom in and you can actually see, you can see it if you zoom in a little bit further. All right. There's two spots we're going to measure. We're going to measure before it starts moving, and we're going to measure it at its furthermost point when it's activated. All right. So here's that spot we zoomed in, and here's the spot we told you we're going to reference against, the first small pulse. And you can see the ignition event takes place 122.7 degrees of crank rotation after the reluctor pulse. How did we get this? Again, we're talking about rotational rulers. If you set up your rotational rulers, if you put your cursors up after your rotational rulers, all your measurements will have time and rotation degrees after them, which is actually a really cool setup. So again, we have 122 degrees of crank rotation after the small reluctor pulse. All right. And if you go to the furthest event and you do the same measurement, you'll see it's 189.9 degrees after the small ignition pulse. So we do some math. 189.9 minus 122.7, and you get 67.2. That's your total adjustment of that. So what we did now is we did a couple things. We, number one, confirmed what service information says, because we've all been there. Service information lies sometimes. But we've also confirmed that this car is working okay. When you're testing vehicles and you're testing new techniques, you always want to test on a known good car. If you're testing on a bad car, you don't know if your test is wrong. You don't know if the car is wrong. You're only testing on theory. So what I did is I tested this on a new car. Now let's say you got 40 degrees of crankshaft rotation. Well, that's a problem, right? Now we know our problem is either an oil pressure problem or a phaser problem. What I would do next is I would check your oil pressure to make sure we're providing good oil pressure up to the camshaft bearing bridge and up to the phaser itself. If all that's good, then I'm going in and I'm inspecting for the broken screen. If all that's good, then I want to take the cam apart, because I like to inspect the cam before I take it apart. I want to take the cam apart and see if you got anything stuck there. Look for sludge, look for something sticking, something like that. It's a great little test. So, picoscope makes it real easy to measurement because it has the rotational ruler function in it. Not all scopes have this ability. Does that mean you're SOL? No. You can do the same measurement using your cursors. Let's take like maybe like a snap-on scope or an Autel scope. All you can do your measurements on are just with your cursors. Well, with a little bit of math, you can do the same kind of measurement. Let's do this. I'll be doing it with a pico, but using basically the snap-on methods. All right. You're going to start by measuring the same area with just your cursors. Okay. Now you can see between my cursors, the same measurement I was measuring before, you have a total difference of 572.8 milliseconds. Write that down. All right. Again, we have 4 ignition events that happen between those cursors. So we have 720 degrees for each firing event times 4 is, again, we get the 2,880 degrees of rotation just like before. What we need to know is how many degrees per millisecond we have, which makes sense. So we have 2,880 degrees, and it took us 572.8 milliseconds to get there. We do a little division, we get 5.02 milliseconds per degree. That number you write down. So now you know in your particular measurement that you have, every 5.02 milliseconds is 1 degree of adjustment or timing. So as before, we're going to measure the cam/ignition relationship before an adjustment. We're using the same reference point as before, the small little pulse of the cam sensor. against where the leading edge of the ignition event will be. All right, the distance between the cursors that we have here is 24.36 milliseconds. Same thing as adjusting the final event. You can see the furthest event is 37.72 milliseconds between those cursors. All right, so you take the 37.72, subtract the 24.36, you get 13.36 milliseconds. Awesome, love math. Totally should have paid attention when I was in school. I wouldn't have needed a calculator to figure that out. So we take that 13.36 milliseconds, multiply that by that 5 milliseconds per degree, we get 67.06 milliseconds. Same thing as before. So again, you can do this test. It's a lot to take in, but once you do the test, you realize how easy it is. All right, do we have any questions before moving on? Because we're about 6:40 right now. So I'm going to go and I'm going to actually go and look and see if we have any questions. Give me 1 second. Questions. All right. And I don't see I have any questions here. Let's see here. I thought I had a question. Oh, here we go. Ah, now I can see questions. Look at this. All right, so we'll start down here at the bottom. Alex asked if RPM will drop while turning on solenoid. Yes, RPM will drop. It'll want to stall. All right, but that only tells you that something is happening. It doesn't tell you what is happening. All right, if you're trying to diagnose the car with a 100% certainty of what's wrong with it, or at least point you in the right direction, you need to know how it's working, which is why you want to do it that. But that's a good question. But we want to be specific about how we do this. I don't want to spend the customer's money on throwing parts at the car. Simon Kern asked, where is the oil screen located? This particular oil screen is located on the back side of the bearing bridge where it meets the cylinder head. All right, and you'll see it there. Okay, let's see here. Okay. Okay. All right, that's about it for questions right now. How are we doing on time? We got about 15 minutes left. So let's go a little bit further if you don't mind. All right, pop this back there. Go here. Since we have a little bit extra time, let's talk about the actual timing chain and everything like that with the car. Okay, here's your basic timing chain setup on the vehicle. You have 3 rows of timing chains. You have your main timing chain. You have your oil pump timing chain down here. Here's your main chain. And then you have your balance shaft chain right here. Another word on the balance shafts. Let me erase this link right here. Go turn the pen back on one more time. Turn the pen back on. So one word on the balance shafts. These balance shafts are pressed in housings, but inside those housings are where the balance shafts spin, and inside those little housings have little screens. Those screens have a tendency to flip, get clogged, and seize up. All right, so what'll happen is you have not quite metal right here on these part of the balance shafts. It's some kind of graphite metally nastiness. Okay, what happens there is the balance shafts will seize, engine will still run, but if you notice back right here, that's the water pump. Volkswagen thought it was an amazing idea to put the water pump on the back of the engine running off of a balance shaft that has a tendency to seize, that's driven by some graphite metal impregnated mess. All right, so your car will run just fine, maybe shake, you know, because it's a Volkswagen and they all shake, but you'll notice you overheat. Okay, so you'll notice that, okay, it's overheating, no coolant flow. Let's change the water pump. So we'll change the water pump, put the water pump on, do it the right way, change the water pump belt, bump on, do the thing, and next thing you know, car's running, overheating again. All right, you take it apart a little bit more, and you find out when the car's running, the belt's not spinning. All right, so what do you do then? Well, at that point, you're pulling the engine out and changing the balance shafts and hoping everything is in there. It's kind of cool. All right, so again, let's get a little closer look at those balance shafts right here. So these balance shafts, because you don't really see it in this picture. Let's see. Okay. So it says it's written right here. I'll highlight it. So again, this is all in the book that you guys can download. And do yourself a favor and download it and save it. The balance shafts are made from spheroidal, I can't even say that word, graphite, cast iron, and run in 3 bearings. So it's basically, it's not even metal. It's really kind of soft. Chain lubrication is provided by oil returning from the cylinder head. Oil is collected and distributed in the chain by a separate lubrication channel. But what they don't tell you is that the little, where are we? Right here, right around here, right around here, here, and there are screens that like to clog because Volkswagen loves their screens. And again, newer balance shafts and newer vehicles that have these remove the screens because Volkswagen finally realized they have a problem. All right. So the balance shafts, again, they live inside the middle of the cylinder head right here on both sides. And they drive the water pump on the back of the engine, which the water pump lives right there. All right, another thing that they don't tell you, it actually used to be kind of like not quite a recall, but a TSB. Pen, turn the pen back on, is where the balance shaft comes out and the water pump gets driven. There's a seal there. All right, that's an oil seal running through a steel shaft. As with any kind of oil seal, and with all of Volkswagens and most modern cars now, the crankcase runs on a little bit of vacuum. That balance shaft is in the crankcase. If that seal starts leaking, the balance shaft or the balance you can get a lean code, and you'll smoke the engine all day long. You won't see anything. Maybe you'll think to take the water pump cover off and look in there and check for a leak. So always keep in mind that that's a spot where vacuum can leak. Sometimes what you can do is you can smoke the engine, maybe spray that down with a little bit of water, look for bubbles, look for smoke, stuff like that. All right. So this is your basic layout of how the timing changer is set up. You see in front right here is your oil pump chain. Your balance shaft chains run on the second plane, and your main chain. Actually, no, your main chain runs behind that. Also, timing chain tensioner, big deal. Always make sure your timing chain tensioner is of the latest update, because those things are junk. You buy a new one, they redesign them. You buy another new one, they redesign it. Just always make sure it's always the latest update that you have. All right, let's move on a little bit. The way they want you to measure timing chain slack or stretch or anything like that is they would like you to measure with a digital caliper. So you don't have to break the bank to get a digital caliper. You can go get one from Harbor Freight, which is under 10 bucks, and then you look, they measure exactly the same thing. You don't have to go nuts. Although I do love my Matco beautiful aluminum digital caliper. So this is how they would like you to check it. This is a picture of the chain, of the balance shaft, everything installed. And they want you to measure, you can see right here, see that guy right there, your intake timing mark. You can see your exhaust cam timing mark. Okay, they want you to measure this in 2 ways. All right, they want you to measure from your intake timing mark right here to this little standoff, the little nubbin and the standoff right there. All right, between the intake timing chain guide mark and the nubbin. And the spec that they want you to be is between 61 and 64 millimeters. We can see right here we're at 62.8. We're in a good spec. The next thing they want you to measure is between the two camshafts. All right, the distance spec on that is 124 to 126 millimeters. So another thing you can do with this is you can also use that spec to measure if your chain jumped. All right, if your chain jumped on the crank or something like that, and your cam to cam relationship is fine, your cam to cam measurement will be fine, but this measurement will be off. It'll let me know that, okay, we got a jump chain. Again, if this measurement is off, but your first measurement is fine, that'll let us know that, okay, maybe we're jumped on the cam right here. Okay, what I did in this picture is you can see that I jumped the exhaust camshaft one tooth. You can see there's about a 5 millimeter difference from the other picture, which is letting us know, on a good chain, it's about 5 millimeters of difference between link to link. Another thing of note, the crankshaft sprocket assembly. If you're looking at this and you're not familiar with this, you're going to notice it's just a round hole. There's no Woodruff key. All right, it's very common, very common. If you take this off, or you take the center, if you take the center bolt out of here, and you're not careful, this could slip and move because the only thing that you have to align it is this little guy right there. And if you really want to, and I mean really want to, you can put this off a little tooth, and you're going to drive yourself crazy because there's no mark. You drive yourself crazy thinking your timing is off and going out and doing a bunch of times, and you just got to make sure that your timing is on. Another mark to be careful of is the outer mark where the balancer goes into, right here. You'll see it's basically round, and if you look really close, let's go back. If you look really close, you'll see it's got a flat spot in there. If you're really not paying attention, you could totally just put that on, feels about right, hit it with your impact gun, and it'll slide and move, and then you got yourself some timing faults. So later on, Volkswagen decided, and later model Tiguan's, I believe it was, is they have a damper holder kit. This guy right there. All right. What that guy does is that holds the crankshaft dampener in position while you take the center bolt out, and you can put in the bolt with the special holder sleeve. And that sleeve will allow you to take the crankshaft dampener out, and you won't lose your relationship of your sprocket to your crankshaft. It's actually a pretty cool tool. It'll fit the earlier 2 liters, but again, Volkswagen didn't spec it out in their instructions till much later. If you want, what I would do if I were you guys is I would write this number down right there. Take a picture of it, write it down, and look into getting that kit. If you're doing a lot of these things, that thing would save your butt. Another thing you can see is there are really no timing marks on the engine. There are marks on the crankshaft, but basically this is a line your links up to the marks, and everything works okay. It's actually pretty simple. If you do everything right and line your crankshaft sprocket up to the right lineup spots on the hub, all you have to do is line your magic marks up, and you're good to go. It's that simple. All right, and that's basically it. Let me see. Before we have other stuff which we can go on later, but before we do that, we should just move on because we're running a little late in the presentation here. All right, let's see here. Let's ask you some questions. Here we go. Pop this out. Let's see. What kind of questions do we have? Alex asks, can a solenoid manually be jumped while running? Yes, it can be manually jumped while running. Be careful though. Only jump it in short bursts. And if you're going to do that, again, your best bet is use the proper front probing connectors. All right. Let me actually turn the screen back on here. again, you're going to want to use the proper front probing connectors, because if you use like an alligator clip or something like that, they'll touch and you'll short out your testing device, cause damage to the solenoid. You don't want to do that. John asks, can I watch this later? Yes, you can watch this later. Sean wants to know, can you provide scope patterns for cam and crank correlation, engine in time and out of time? If you email us, I can get something to you. I'm not going to provide anything right now for you because it's not on this particular computer that I have. All right. Could that show wear if the measurement is more than the spec? If you're talking about what we're doing with the timing chain, yes, that's what that test is designed for. That test is designed to show timing chain stretch. But if you do it in a certain way, you can obviously infer that the timing chain is jumped as well. The test that we did with the camshaft phaser, you could show wear in that phaser as well if it's over adjusting, but generally it wouldn't because you're stopped by the vanes. Let's see here. Fire video. How often does the screen particles make it over to the dead end? Depends how it breaks. You're talking about the oil mesh screen. All right. The oil mesh screen, if it breaks in a certain way where it just slowly turns into kind of like a silt kind of material, they are small enough to make it up through the bearing bridge, through the adjuster valve, and then into the phaser itself. Anything can happen. That's why it's important to try to find all the pieces that you can. All right. Is it safe to say that the digital measurement specs are all for the 2-liter? Yes, for this engine, yes, the digital measurement specs are for the 2-liter engine. You would have to get service information for your particular engine and read that and infer that test on your own. But the methods are the same. Even for the old 1.8T engine, the way that works is you have a camshaft tensioner in the back of the car that either tensions the chain up or down, moving the exhaust cam, one of the cams. And the test would still be the same. You would still reference off the same things, and you would activate that solenoid and measure it all in a scope. Test is always the same, and that specification is in service information. So I think that's pretty much about it. Again, if you have any further questions, feel free to ask that at info.us@autologic.com. We're going to have another upcoming webinar. It's going to be what's new with the Drive Pro. If you guys are Drive Pro customers, you'll notice that a lot of changes have been happening recently, and we're going to cover some of those changes. We'll go again over how to use the tool to its fullest potential, and it'll actually be a pretty great webinar. It's going to be hosted by Vince Walsh. He's a great guy, still owns a shop. He's a tech support guy over here. It's actually really great. All right. So with that, I think what I'm going to do is I'm going to say goodbye. So let's do one of these guys. I'm going to do this. And I'm going to turn my camera off. And that's here.